All right, well, they don't give us much time to do these things, so I'm going to get started. I know after lunch sometimes people start to pile in during the session, but in any case, this is a session on a somewhat obscure topic, which is why it actually fits in well with a smaller format like this. This is a session on protecting SharePoint content databases using a SQL technology called Transparent Data Encryption, or TDE. My name is Michael Knoll. I work for a Microsoft Gold partner based out of the San Francisco Bay Area. I do a lot of work with clients in the Bay Area, but I've also been to Australia many times. I've been now every place except the Northern Territory. I plan on hitting that tomorrow, incidentally, so I'll complete my conquest of this country very soon. Great place. I always love coming here, and especially I've presented at a couple other tech eds in the past, so a couple other Australian tech eds. The work that I do at CCO is implementation work, architecture work, infrastructure work, and security work. I do it in SharePoint as well as with Exchange, Active Directory, Forefront, and the System Center line of products. So we'll go into clients and we'll design an entire topology that involves a lot of different Microsoft products as well as in a lot of cases third-party products to address specific business needs. One of those needs has been needs around data encryption and security, which is how we got introduced to SQL Transparent Data Encryption. In addition to the work that I do at CCO, I'm also the author of several books from SAM's Publishing. The most notable and the most recent would be SharePoint 2010 Unleashed. SharePoint 2010 Unleashed actually has a specific section that goes into detail on TDE as well. So if you're interested in the step-by-steps and that type of thing, it's in the book. Actually, there's a few copies floating around. There was a giveaway yesterday of the books after the first session that I did. This particular topic, we're going to take a look at some of the different encryption options and how they differ from TDE. We'll take a look at why you'd actually use TDE in a SharePoint environment. And then we'll have a quick demo of actually turning on TDE on a SharePoint content database. So we'll quickly illustrate how to set this up. It's not actually that challenging to configure and set up, but there are a few things that you should note before you begin the encryption of some databases. So really, you know, the problem that comes out of this is, in a lot of cases, we have organizations that have mandates that data, when it's at rest, is encrypted. Some of those mandates are governmental mandates, some of them are industry mandates. But in a lot of cases, they expect that the data itself is going to be sitting in encrypted format. Well, by default in a SharePoint environment, there's no encryption at the SQL level. So you could take a backup of a SharePoint content database and bring it over to a different environment, and you'd be able to do whatever you want with that. The fact that there's security ACLs on the content doesn't mean that someone who has full rights to that content database from the back-end perspective couldn't go through and just re-ACL everything. So there's really no built-in security at the storage level. So in a lot of cases, clients, you know, are realizing that they need something to provide for encryption of that content database. But at the same time, they want to be able to do it without having to affect SharePoint, because by default, SharePoint doesn't have a checkbox that you can say, encrypt this database. SharePoint doesn't do any type of encryption in storage at all. So the solution is data encryption, something like TDE. However, there's a bunch of different data encryption options, so we'll talk through those different options. Some of those options require the application to support them specifically. For example, cell-level encryption, which is an encryption option I'll talk about here. That requires the application to be aware of the encryption that's going on. It requires the application to have a key to decrypt it. That's something different than with TDE. TDE is completely transparent, hence the name. It's transparent to the application itself. The encryption happens at the SQL tier itself. So cell-level encryption, this is a SQL concept where you take individual cells within a database and then you encrypt those cells. It requires a password or a key every time you open up one of those cells. Unfortunately, in the SharePoint environment, this isn't supported. So you can't use any cell-level encryption. If you have a SQL DBA that's familiar with this and wants to put it into place, it's not supported because SharePoint would need to know how to decrypt those individual cells. SharePoint would lose access to the content database if you put cell-level encryption in place. So not an option for a SharePoint environment. One option, an additional option that actually technically is supported is file level encryption. So you could actually take the file system where the databases are stored and encrypted. Not necessarily recommended. There's a lot of disadvantages to using file level encryption, but it's EFS or BitLocker. These are Microsoft's file level encryption, as well as some third-party products that are out there that would completely encrypt the file system itself. On that note, by the way, we do have some clients that they're SAN vendors specifically support encryption more at the actual SAN level itself, and so that's even independent of SQL. And so we'll have some clients that use that to overcome these limitations. But I'm talking at the software layer. I'm not necessarily referring to SAN-specific technologies. But like I said, it's not really, the EFS or BitLocker type of options for SQL environment are not really the best for SharePoint because there's a heavy performance hit. There's no support for things such as prefetch or asynchronous I/O options. And essentially, your I/O becomes bottlenecked at a certain point. So really, SQL itself was never really intended to use those file-level encryption options, even though it can be used. And then we do use it in some smaller clients because it's relatively straightforward to set up. But things get bottlenecked, serialized. You don't get a lot of performance out of those types of environments. And the backups themselves are not encrypted. Once you back up the database, that backup tape resides in completely unencrypted format. So. One other encryption option I should talk about, because it technically is a form of encryption, is a rights management technology called AD Rights Management Services, or ADRMS. This is a encryption technology that allows you to control what happens to your content after it's been accessed. So, of course, SharePoint has a very good security model. You put ACLs on files and say, I only want user Joe to be able to access this data. Well, once Joe accesses that data, after he's accessed it, at that point, he can do pretty much whatever he wants with it. He can send it outside of the company. He can make a copy of it. He can print it out. So from an information security perspective, a lot of clients are looking to control what happens to that data after it's been accessed. And that's where something like AD Rights Management Services comes into play, because it can actually go through and help by restricting what you can do with those documents afterwards. So it restricts cut and paste. It restricts things like print. Of course, if someone's determined enough, they can pull out a digital camera and take pictures of the screen. I mean, there's always ways around this, but essentially it's a way to slow down an information thief. This works also through a PKI-based encryption. So there's an encryption that's actually added to the documents themselves. It's an independent layer of what happens at the storage layer. This is at the rights layer of SharePoint. So you can use it together with TDE at the same time. It's just protecting your content in a different way that TDE would protect it. Okay, so SQL Transparent Data Encryption. This is a technology that first came out with SQL Server 2008. It's available in SQL Server 2008 R2 as well. It is only available in the Enterprise Edition, so if you're running the Standard Edition, unfortunately, it's just an Enterprise Edition level technology, so you'd have to be running the Enterprise Edition. We do have some clients that will turn it on, or will have like a SQL server that's just for their encrypted databases, and that's the one that runs Enterprise Edition, and then they have some of their other databases on a Standard Edition server. There's various ways of setting that up, especially since the SQL licenses are licensed per processor, so you could have a machine with essentially just one processor that runs Enterprise Edition, runs TDE, and then another machine that has more additional processors. Various ways of architecting it, but essentially it's only available with the Enterprise Edition, and it does seamless encryption of individual databases. You can theoretically do any database you want. You can encrypt your config database, but it wouldn't make a lot of sense to do so. SharePoint doesn't care. SharePoint is not even aware of what's going on. SharePoint communicates to SQL across port 1433 just like it normally would. It doesn't know what's going on. It doesn't know that there's any type of encryption happening. Once its request hits the SQL server uses its key to decrypt the content and then send it off to SharePoint. So it's all transparent. It's all handled at the SQL tier. And you can turn it on or off of databases at whim. So if you want to turn it on in this database and later turn it off, you can do that. There is, of course, an encryption and a decryption process that it has to go through, and that may take some time depending on the size of your database. A couple key things to note. When you are encrypting any database within an instance, note that your tempdb file is also encrypted. It fully encrypts the tempdb. So what that means is that if you have a lot of SharePoint databases running on a single instance and only one database is encrypted, the tempdb file is going to be encrypted for the entire instance. And since all transactions that go in and out of any database that's part of that instance use the tempdb file to write, you could actually have kind of a performance slowdown in that case. So if you are enabling TDE, one of the things I'd recommend is that you actually set up a dedicated instance just for your encrypted database, and then you have a separate instance that's used for your non-encrypted databases. That way you have better performance overall. Other things to note, any snapshots you're making of that server, any backups, or a mirrored database instance. So if you're setting up SQL database mirroring, a topic I talked about yesterday at my infrastructure session, it will actually set it up to mirror the encrypted content from one server to the next. Now you do have to have the key on both of those servers, on both the principal and the mirror server, but it encrypts the data not just in storage but also in all of its forms as it's being sent out, with one big exception, which I'll talk about, and that's RBS, blob storage. It operates at the I/O level through the buffer pool, so any data written into the MDF is encrypted, and the backups can't be restored to another server without actually restoring first a copy of the key over to that other server. So that's exactly the way you want it to work. If you're encrypting your databases and someone steals the backup tape, you don't want them to be able to restore it to their machine. So, and we'll see that what kind of error message they get if you try to restore that database over to a different server. The overhead is actually not that great. If you set it up properly with its own dedicated instance just for the encrypted databases, we're talking about a 3 to 5% performance hit overall, as opposed to something larger. So it's really not that big of an overhead to enable it, especially if you have available capacity on your SQL server. Some limitations to TDE. It's not encrypting the communications channel. So the channel between your SharePoint servers and the SQL backend, for example, that's not encrypted. So if you're pulling up the database, it's a highly sensitive database. At the point that SQL decrypts that content, it now passes it across the network unencrypted over to the SharePoint server for SharePoint to do something with. So if somebody is monitoring that, if your network admin goes and sniffs the port on the SharePoint server, they can view that content decrypted. So it's not a communications channel encryption technology. You would want to use something like IPsec in that case to make sure that you're encrypting the communications channel. It does not protect the data that's in the memory. So that means that if somebody is a local administrator of the box or a DBA can actually access the memory on that box, they could potentially access confidential data, because as it gets decrypted, it gets put into the memory and then it's sent off to SharePoint. So bear in mind, it's not encrypting the memory itself. If you're using SQL Server 2008 backup compression, it's not a technology that you can actually use as well. And then tempdb itself is encrypted for the entire instance, as I mentioned earlier. Oh, the last thing, by the way, if you're using replication or file stream data, that data itself is not encrypted. So that applies to RBS, remote blob storage. RBS is a concept, if you're not familiar, where the blobs, which are the documents in a SharePoint content database, the blobs are stored on a separate file location than the actual content databases themselves. So since 80 to 90% of the size of your content databases is oftentimes blobs, the blobs themselves, if you remove them off using the concept like RBS, you can reduce the size of your content databases by approximately 80 to 90%. Downside when you're using TDE is the blobs are not encrypted. So if your requirement is that it's encrypted in storage, you not only need to use TDE, but that blob storage location also has to be encrypted either through something like BitLocker or EFS or a third-party encryption or one of those SAN encryption technologies I talked about. Okay, so let me actually skip this slide and show you, just kind of walk through the graphically what we're talking about here. There's a key hierarchy when it comes to the keys that are used to create TDE. Some of this is more academic than anything else, but basically at the OS level, when you install Windows Server, there's what's called the Data Protection API, which itself goes through and encrypts a service master key when you install SQL Server. So right when you install SQL Server, the DP API goes and creates its own service master key. That service master key then is used to encrypt the master DB. At the master DB level, you create this what's called a database master key. The database master key then is what's used to create the certificate, and this is the certificate that you would then take over to another server if you needed to restore the databases, for example. So this is the TDE certificate that's created. And then what happens then is that certificate is used to go through and create a database encryption key at the content database level. That database encryption key then is used to encrypt the actual individual content database. So there's this hierarchy of keys that are used to encrypt the content. But it's really, most of this, the first pieces of this are the keys that are related to SQL itself. Once you get to this point that you actually start to be able to back up those keys and bring them over from one server to the next to be able to recover data in an encrypted database. So the high-level steps to enable TDE. As I mentioned, this is not actually that difficult. There's just a few TSQL scripts that you run that you can customize. So you can download this slide deck, you can go through and copy and paste them if you want. It's basically about 6 different steps that you go through to encrypt an individual content database. The first step is to create that database master key, or that DMK. So it's a symmetric key that's used to protect the private keys and the asymmetric keys. It itself, again, is protected by that SM key, which is created when you set up SQL Server. And the syntax is relatively straightforward. You can plug this right into a TSQL script. You can put in a password that's used to encrypt the actual key itself. Hit go. It creates a DMK on that server. The certificate, the TDE certificate that you create then, this is the one that you would bring over to another server that where you're restoring the database to. It's protected by the DMK. It's used to protect the actual database encryption key, and the syntax is fairly straightforward. You name what you want the certificate to be. You give it a full name, and you give it a short name. Hit go. You've got yourself a encrypted certificate, a TDE certificate that then you would bring over to another machine. Important step, back up the master key and the certificate itself. What this does is then it goes through and makes sure that you can actually restore the data that's in these encrypted databases. Obviously, it would be a big problem if you lost the key, and even with the restore or backup of those databases, you wouldn't be able to recover them. So make sure you're backing up the master key. In this case, it's, again, fairly straightforward syntax. I'm just backing it up to some local location. I'm backing it up with the private key. I'm giving it an encrypted password. Hit go, and you've got yourself a backup of that key itself. At that point, then you can go through and actually create the key that's used to encrypt the individual content database. So it's used to encrypt a specific database itself. There's one key that's created for each database that's encrypted. You can specify which algorithm you use. So you can specify different types of, there's various different types of algorithms. The default is AES 256. Some of these are more secure than others, depends on what your requirements are, but you can go through and encrypt with different types of encryption keys. But essentially, you'll note that we're using the certificate that was created in the earlier example. That's that TDE cert that I created here. I'm now specifying which database is actually being encrypted. You change this to the name of your individual database, hit go, and it goes and creates a key that's used to encrypt that database. It hasn't actually encrypted it yet, but it creates the key itself. And then go through and enable TDE. You run this specific command. You say, use this database, alter the database, set the encryption on, go, and your encryption process will start. You can monitor the encryption process by, again, another fairly straightforward command that goes through and specifies, okay, show me the databases that have a specific encryption state. The 2 types of encryption states are, well, there's 3 types. 1 means no encryption at all. 2 means the encryption has begun. And 3, the encryption is complete. Depending on how large your database is, it may not take that much time at all, surprisingly. You should note that theoretically you can have people working in your content database while it's being encrypted. However, there can be some user locks in some cases, so I would normally wait for kind of a quiescent time when you're actually going to run the TDE process. And then restoring that encrypted database to another server, the steps pretty straightforward. Create a new master key. It has nothing to do with the source master key. Back up the cert and the private key and restore those cert and private key onto the target. and then restore the database itself. So again, if you want to play with this yourself, go through the process, download the slide deck, and you can just throw these into TSQL scripts. Okay, so quickly, we'll go through and just kind of take a look at essentially, this is a video that I did previously on setting up a TDE on a simple database. So the first step here is where I create that DMK. So I'm going to create the DMK using the TSQL script. It should complete successfully if you have your syntax correct and you have an cryptic password set up. At that point, the next step is to go through and create the database encryption key. So you'll note now I'm actually creating the individual TDE certificate, and this is again the one that you'll need to store separately from your backups, but make sure you have it in a secure location. Execute that. That creates the TDE key itself. Now the TDE key can be used to actually go through and create the individual or to back up that encryption key. So as I mentioned, important step. If you forget this part and you don't have a backup of the key, you're going to have some issues. So I'm backing up the key. In this case, I backed it up to I'm going to create a backup location, back it up into this individual location. Here we go. Hit execute. Put in the password that's in there. Again, you can modify any of these whichever way you choose. That backs up the individual file itself. The individual file then you can copy over to another server. In this particular demo, that's what I was doing, is copying over the individual backup file over to another machine. And then go through and actually create the individual key itself, which is going to be used to encrypt the database. So that's successful. And then step 5 as part of the process, I'll actually go through and take that content database, alter the encryption state, turn encryption on, and that will start the process of encrypting that content database. So click go, and it's actually starting. It'll go into that database and start to encrypt the content within that database. I can now go in and specify, take a look and show me all the databases that actually have a specific encryption state. Of course, you could do this en masse to a large number of content databases as well. There's different ways with TSQL to set that up. But when I run this, you'll note it actually completed fairly quickly. You'll note it took just a few seconds in this case. Obviously, I didn't have a lot of data in this content database, but to encrypt this actual individual file, it didn't take long at all. It also encrypted the tempdb file, which is the other database that's up here. So it went through, encrypted the tempdb, encrypted that content database, and at that point, when I back up this content database, it will be backed up with the encryption that's stored on it. So I'll go through and back up the individual file and restore take that backup file and bring it over to another SQL server. And what's going to be demonstrated then is the process of trying to do a restore on that server and seeing if it will even restore. If it's been done right, it should show an error saying that it doesn't have a key to be able to decrypt this individual content database. So that's essentially what I'm doing, is copying the database file over at this point, and then we'll try a restore of it. Again, bear in mind, it's the one thing that's really good about TDE is that you don't have to commit to anything. You're not committing to any type of third-party application. Not to say that there aren't good third-party applications, but you can basically just turn it on or turn it off at will. If you have somebody that says, for example, okay, the human resources database has to be encrypted, very easily, if you're running SQL Enterprise Edition, you can just turn it on, and then at that point, you've got encryption. There's one specific state law in California, for example, requires that any information that's includes someone's credit card information. So if you have a database with credit card information, it has to be encrypted. It doesn't matter what happens. As long as it's encrypted in storage, you've complied to the letter of that law. So in those cases, if you actually have credit card information in a SharePoint database, we've had clients in California that just go through and enable TDE. So this is what you get on a server that doesn't have it. I tried to restore that database over to another machine. It's looking for the thumbprint of that certificate, and since that thumbprint doesn't exist, it doesn't allow you to restore that database. If you go through and actually do the restore of that certificate file onto that other machine, then you'll be able to restore the certificate. It'll be able to decrypt it, and then you can turn it off. Or at that point, you have full rights to do whatever you want to that individual database itself. So I have 4 minutes for questions. Any questions? Came just in time. You came for the other guy, didn't you? Yes. So the question is about performance hits. It's generally about 3 to 5% of the processor of the SQL Server. It does depend. There's a lot of variables that are involved with it. But yes, there is a performance hit for the individual database, but it's not a significant performance hit. Other questions? Yes. In EMC, there's what, sorry? That's next session, yeah. I'm like, fast search. Okay. Other questions related to TDE? Anybody? Well, I got 3 more minutes. I try to make sure. Okay, I've got 3 minutes to answer any question about SharePoint you want. SharePoint infrastructure. Anybody? Anybody? Dan in the back? No? Come on. You love the what, sorry? The picture. Yes, yes, yes. Actually, a lot of times people ask, well, how'd you get up on the Golden Gate Bridge? It's not like Sydney, you can't just walk the bridge, right? It's not, you have to have special rights. But fortunately, one of my clients was the Golden Gate Bridge District, and after we were done with the big project, we went up. There's a very, very small lift that goes up the tower. It's about, I'd say, I don't know, 30 centimeters by 30 centimeters. It's really, really small. And so you go inside, and it goes up to the top, and you come out, and then you're on top of the Golden Gate Bridge. So, yes? I don't have any more copies of the book, sorry. They were all given away yesterday. You may be able to barter for them, though. So. But, within, at about, we're timing for release of SharePoint 15, we're timing SharePoint 15 Unleashed. SharePoint 2010 Unleashed was about 4 or 5 months after the release. This year, this release, we're trying to get it out right on time, which is difficult, especially since when we do it right on time, we always insist that everything is run against RC, so there's a big time crunch to finish that stuff. But we already did start work on SharePoint 15 Unleashed, so we're hoping to get that out right on time. At a Microsoft event? Come on, really? Any other questions? I have 2 more minutes. Yes? Yes, the book goes through, has almost the exact same examples, and it's in chapter, now I'm forgetting my chapters, but there's a chapter that's on SQL Server that goes into detail. It does that, it does SQL mirroring, and it does, what else does it do? A couple other things about SQL related to SharePoint. Was there a question here? Yes. I'm sorry, could you repeat the question? When you encrypt the database, can anyone access it? Oh, can the DBA? Yeah. So as long as the DBA is doing it from the machine that has a copy of the key, yes. So in other words, from the SQL Server itself, they can access it. Yes. So yeah, it doesn't solve that particular dilemma. Any other questions? 1 more minute left. Yes. When I set up a SharePoint farm, do you recommend? SQL aliases. Yes, good question if you should use SQL aliases when you're setting up the farm. I still do use them. They're not as important as it was with 2007 because in 2007 you didn't have, we primarily used aliases in a lot of cases for SQL mirroring because you'd need to switch it over. SharePoint 2010 is now mirroring aware, so you don't necessarily need to do that. However, that said, in almost all the installs we do nowadays, we still use aliases because it gives you flexibility to move your data around. So yes, I do use SQL aliases quite a bit. If you change the name of the config database, or I'm sorry, move it from one server to the next, it saves you a lot of headache when you do that. So that said, I'm now officially out of time. So appreciate you guys coming.